Thank you. I've already got a dry mouth, so excuse me for 1 second. But thank you for coming down. It's a real pleasure to be here. I am Steve Spencer, and I work for Reaktor, and I do data engineering day in, day out, and I have done for the past few years. I guess I've started in my data engineering career in a small startup a few years ago, and then I've also worked at quite a large games company, and my day-to-day work involves helping companies increase their capability to do data-related projects. So you could imagine that I was pretty surprised when I opened my laptop one morning and got this message in one of the public forums for the company Slack channels, and I was like, right. And the worst thing was that was actually a friend of mine who did this, who shall remain anonymous. And I was gutted. I was absolutely it ripped my heart out. So I sort of then got another cup of coffee, cleaned the old one off my desk that I had spilled everywhere. And I was going to get together a really, really witty reply, something really biting and concise, but then I had actual work to do. So I thought, what better than to actually do it in public here for you today, and let's see what we find out. So one of the weird things I think about data engineering is it's not the superstar. It's simply a means to get something done. We move data from one place to another, we transform it, we make it available for other people to do their job, we integrate various data sources, but what's the ultimate goal of all this moving? And how does it then differ from any other job that involves the same sort of moving? So I suppose, like, in addition to being completely denied my entire existence, a lot of people get a little bit confused, and they go, "Steve, are you a data scientist?" And I say, "No, I'm not. I wish I was, but unfortunately, I'm not." And then they go, "Oh, is it sort of like data warehousing?" I'm like, well, there's a sort of element to it, but what's then essentially the difference between the data warehouse developer guy and a data engineer? So I think it's quite a simple answer. The answer is actually in the title. So when you have a problem and you want to solve it, if you're a data warehouse developer, the answer is always data warehouse. And if you're a data engineer, data warehouse might be one of the solutions, but there are many others up your sleeve. And that's usually my response to people who ask me what I do. And I suppose that when we think about what the ultimate goal of, say, if you're a data warehouse developer, is to build this data warehouse. And it's supposedly something that's going to be perfectly architected for fast retrieval of data, and you're building this data warehouse for queries that you don't even know that exist yet. So you're optimizing for a workload that will come in the future. But for data engineers, it's not quite the case. We think about, like, what defines a data engineer as opposed to a data warehouse developer is that we support data science. And the workloads typically differ quite a lot. So data science is the key here, and they are quite sexy. I am not one of them. But if we cast back to 2012, this is an article from Harvard Business Review, and it was a few years ago, 2012, and it's the sexiest profession. And good on them. You know, I think they deserve a lot of respect. I work with a lot of them. and everybody wants them, and everyone wants to be them. So, and one particular thing is really interesting, how they absolutely nailed it in their prediction, is that the basic skill that a data scientist has is writing code. And back in 2012, data scientists were absolute unicorns. They were amazing, rare beasts in the wild that you would see. And now that the demand for them has been so strong, we have people who are trained to be data scientists, but they might not have all the skills that you would probably find in a typical software engineer. So, and this, I feel, is why we have this role of data engineer, to fill that need for software engineering in data science projects. And so I'm going to paraphrase, this is another quote from the very same article, that when these data scientists were rare unicorns, now not so much. I would hazard to say in the current climate that data engineers are the unicorns, although they're not quite as sexy, but they're still quite necessary these days. So I think one of the fundamental differences in approaches I've seen working on the ground is the data scientists are mostly concerned with the result. Is it correct? And data engineers are mostly concerned with some of the typical things that you would imagine like a software engineer would be interested in. Is this code scalable? Is it maintainable? And is it correct as well? But these things are sort of different concerns. So now that we've sort of established that sort of data engineers is a special case of software engineer, we can sort of cast our mind back to the sort of mid-late 90s to this particular publication by Eric Raymond. And it's one of my favorites. And at the time when it was released, it was quite an interesting insight into the Linux development process. And it sort of blew a few minds. And I'm going to steal something from it. So Raymond actually goes on to describe this top, like, sort of big design upfront process versus a more sort of marketplace way of thinking about software development. And I think like this is something that certainly doesn't happen and as much as I'd like to see in data science projects. So when we say like, we have sort of two different approaches, and usually the cathedral approach is that we build these enormous, fantastic contraptions that are sort of the pinnacle of sort of architecture, and they're beautiful and they work quite fantastically, but it takes a long time to do these things, and we might not know that they actually fulfill a function after you've done. And the bottom-up approach is more, I'd say, sort of grassroots level software development, where we would actually build things and have contributions from various people. But he also goes on and with so many lessons, and some of them are quite relevant to, I think, running a data science project. But he's sort of eloquently used this cathedral and bazaar terminology. And so what I like to think of the two different approaches in context of data science projects or data engineering projects, rather, is the underpants gnomes scenario. And what generally happens, I think, if you're considering starting a data science project from scratch, I suppose the first step is to get some data. And usually we just collect everything We then figure out what those use cases are going to be like, and then we will, and hopefully they'll turn up at some point. But in the meantime, we're busy maintaining, building these amazing sort of data storage mechanisms, and then we're hoping to make some money sometime along the line. But we're basically building capability all the time that sometime down the road in the future, we're going to be able to sort of take advantage of these new capabilities, but we don't really know what the point of that was. And so in the same way, Raymond says a little bit more eloquently than I do, but I like to think of the bazaar model in context of data as more like guerrilla tactics. So when you're building the application, you have a clear idea of what you want to achieve first, and all the data mechanisms should follow that, support that use case. So you just build what's necessary to get the job done, and you kind of worry about the future sort of down the path. And then if it's good enough, then great, you're done. But then you can also then iterate and improve what you've got. And it sort of applies to data infrastructure as well as code. So we like to say that, you know, embracing the chaos is something that's kind of core to the data engineer sort of ethos. And I think that it's sort of very common, I think in the data engineering space, is that we talk about amazing frameworks, amazing cloud providers who are providing these awesome managed services, and they're fantastic. But I think very rarely we actually talk about the actual methodology of how you go about tackling a particular problem. And I think that's a real shame, because it's quite a fine topic to talk about. So, thinking about guerrilla tactics, I want to tell you a little story about when I was a young data engineer. In fact, my very first data engineering job, I was at this startup, and it was my first day. My first day, I came in and I sat down with the head of data science, and he said, "Steve, we have a problem, and we need your help." And I was all ears. But I'm going to foreshadow something a little bit now. This is actually a quote from Cathedral and the Bazaar about smart data structures and dumb code being better than the other way around. And that's one of the key points that I think that that Raymond makes, which is really applicable in this particular case. And it's kind of weird, because I kind of hit on it on the very first go, on the very first day of the very first job that I did as a data engineer. So, talking to the head of data science, and he says, "Yes, we have a problem. What?" And I say, "Yeah, okay, that's why I'm here." And he goes, "So we have a bunch of documents. We want to then, given a particular document, we want to know and build an API that sort of says, hey, if I've seen this document before, return true, and if it's a completely unique new document, return false." And that seems pretty straightforward on the face of it. And I thought, oh, well, that's not a problem. And so he gives me just one caveat, one constraint, is that this particular feature, this is actually necessary for the launch of the product in 2 weeks. So all the marketing, all the press have been informed. It's up to you. I'm like, okay, that's fine. It's my first day. So it seems quite easy, but there's a huge number of documents between, in the tens of millions, perhaps even more. It's sort of unclear at this stage, but we had at least tens of millions at the time. So naturally, the first thing that we think of is that we can't fit them all in memory on one machine. So, okay, that's not a problem. Yeah, we have a little sort of Python-y pseudocode And so it's never going to work. So then, okay, the second idea is that, okay, we don't need to store the whole document. There could be, hundreds of K, some megs of sort of space used by each document. Let's just take certain features. Let's create a fingerprint, a summary of this document, and store the fingerprints instead in memory. It turns out there's too many for that too. But we've sort of also introduced this idea that we can lose some information. We don't need the entire document. So we're happy to make an approximation if we've seen this document. So that's an interesting sort of concession there. But we're still not really there yet. But still too large for one machine, unfortunately. So had to keep thinking about this. So I guess the other thing is that the next step, and you're probably thinking is, well, like, okay, let's just store this in a database on maybe another machine. We can then query this over the network and just check maybe in a table, maybe in a key value storage. Let's progress like that. Fine. And it's just we could probably get our cloud provider to then provision that. That's quite easy. If we needed more machines, we could have a nice sort of distributed key value solution. There are many of them. That could work. But the one particular problem is that in our workload that we would query that API hundreds of millions of times, and we had a limited kind of time window to get it all done. We would never sort of be able to perform all of those membership queries in that particular time frame. So the idea of having something over the network and that latency would be game over. The marketing budget would be blown, and we'd probably all be sent home, and all our stock options would be worth zero. They were worth zero anyway, but and that's why I'm here today. But actually, the solution came from something that was like really old. So we sort of didn't go for any sort of fancy tech stacks or anything like that. We ended up implementing a Bloom filter, or we actually just took one straight off the shelf, and this solved our problem. And so it's a pretty interesting piece of data structure work from 1970. So this is the old thing that we use. So it was invented by a lovely man named Bloom, and what it does is answer set membership queries in constant time, and it's so simple. It's just basically an array. So we initialize an array like that. We can choose how long it is, up to depending on our use case. And how it actually works is that we have several independent hash functions. In this example, there's 3. And what we do is each of those hash functions then maps to an index in this array. So we initialize the array with all zeros. And for example, this x, we run these hash functions across x represents a document in this case. We calculate the results of those hash functions, which are indices, and then we flick the appropriate index to 1, regardless of what the initial value was. And so we would do the same thing for each other document. So we're adding them, populating our Bloom filter for Y and Z. And we can also take note that the second, that Y actually hashes, one of the hash functions sort of goes to the same index there. So that's a pretty simple stuff. So all you need is an array and some independent hash functions that map to those indices. And so that's the population of the Bloom filter. And then when we want to actually then query it and say, hey, does this document or does this entity belong in this set? We do the same thing. We run those hash functions. So if we take a look at W, we run those same hash functions, and they map to indices in that array. And then we check, are all those bits set? And you can see in this example that one of them is not set, so we can then conclude that W doesn't belong and move on with our lives for great fun. But it's really old, and one of the nice things is that it's constant. The space that it requires is constant, but one of the problems with it is that it's actually it can return a false positive. So we're sort of losing information by hashing, which is fine. We've already sort of conceded that, yeah, if we take fingerprints, we're going to sort of lose some information, but we can sort of live with that. So, and we can sort of define or manage this false positive probability by the length of the array and also the number of hash functions. But it's amazing. I'm still quite excited by it. 40 years later. Okay, so we're back to the problem then. So instead of going directly to the data source and for each query, we then go, we query the Bloom filter first, and then we go to the database if we need to. So in this particular example, I've put up some pseudocode there, but we're actually checking to see if the Bloom filter contains this document, and then to mitigate the false positives, on the third line, we retrieve from the database. But if we're cool with some false positive, we don't need to do that. But the really cool thing is that the negatives are 100% correct all the time. So we save all those calls to the database when they don't belong to this set. And for this particular workload, that probably about 10% were sort of duplicate documents. So we could then basically cut out 90% of our database access over the network, which is amazing sort of saving. And of course, when you're under time constraints, then that's a really, really important thing. And so instead of being sort of in the millisecond range of we would think about it as being, a few instructions just to calculate those hashes. So the good news is, as I said, that we managed to end up shipping that product. We ended up having some more sophisticated ways of handling this situation, but this was sort of a really good example of that when thinking about data engineering in a data science project, that our use case really needs to come first. And all the investment that we would have made in, say, for example, in storing our data in a very efficient manner in a data warehouse would have meant really not too much in this particular case. So we would have lost quite a lot of time and probably not shipped a product that went to market and ultimately didn't make any money anyway. But it was a lot of fun. Yeah. So I suppose to answer my colleague who dissed me so publicly in the forum, that I can confidently say that data engineering is a definite thing. I do it. And the other thing I can definitely say that it's also just a specialization of software engineering. So, and that's a really wonderful thing, because I think a lot of people are very familiar with software engineering, and if you're interested in doing a data project, then you probably have all the skills you need already to go ahead and do it. And if you are considering doing such a project, then maybe your first stop will be at a data scientist, which is a very excellent choice because they're very sexy. But maybe don't underestimate the need in your data science project for a data engineer, because they're really important. Because essentially, when it comes down to when the sort of wheels hit the road, it's all just code anyway. Oh, I thought I'd got through without the skipping. Yes. Thank you very much.
stay right there for the Q&A.
I feel like
you're not off yet. Thank you very much.
Thank you.
I feel like I learnt something.
Oh, good. I thought I have learned something too.
Related to kind of your last point, I wanted to kind of get in first and get my question in. Are there certain kinds of projects, do you see projects where you kind of wish you'd been called in, or where a data engineer had been called in, where you could have provided kind of a special value?
Yeah, I think that I talked a lot about sort of doing sort of how, I guess, rather than concentrating on what technologies we should use and more on the methodology, I think that there was like some projects I think that would be really, really good, that the ones that sort of are focused on those building huge data warehouses and concentrating on building the perfect snowflake schema and so much energy to go in dimensions. And I really wish that instead of starting with that, maybe starting with the data scientist and data engineer on the premises, because then it usually maybe you could invest like maybe 1 or 2 years and potentially a lot of money and not really get any real tangible benefit out of it. So in those cases, I really wish that would have been the case.
Yeah. Do we have any questions in the room at the moment? Stick your hand up if you do. Let's go online, because I've got a couple there, or at least one. Someone asks, what is the next data insert profession hype going to be about? Who's going to be the next sexy thing?
I don't know. Well, I don't think it's going to be data engineering, and I suppose that was the sort of one of the things that I sort of wanted to debunk, because everybody comes up to me and they say, "Are you a data scientist, or are you some sort of ETL dude?" But I think that data scientists will remain quite sexy and quite relevant, and as this sort of transitions, I think, under the umbrella of AI, so that AI engineers and the AI specialists are probably now the new hotness.
So AI is the new data?
Yeah, I think so. It's a great rebranding, but I think the data scientists are quite clever like that. They
know how to brand themselves.
I know. I should really learn from them. Like, I should maybe sort of rebrand myself a little bit.
We can try and find you a new title if you like. Any other questions in the room at the moment? I'm trying to kind of peer through. No, I think we're going to let you off and go grab some lunch and coffee.
Okay, yes. Oh. Thank you very much for...
Thank you, and do tug at Steve's sleeve if you want to ask him questions later.
Yes, I'll be around and moving data from one point to another somewhere in the building, so yeah, come and say g'day, and happy to chat.
Awesome. So. Cheers.
All right.
Thank you, Steve.
Thanks, everyone.